It does not matter whether you are a college boy or a college going girl, whether you are still studying or have just graduated from your college. Anyone, including professionals who are looking for a SAS course which can make their future brighter, then this course is for you. As you already know, SAS is being used all over the world in marketing, big pharmaceutical industries and health sector, banking and financial sector, real estate industries, telecom and engineering sector, and even in education sector as well. In this course, you will learn SAS programming by doing. That is, build concepts using various examples and challenging quizzes that will start preparing you for Base SAS certification exam from day 1. Are you fed up of nonsense courses that make you cram? Then don't waste your time and grab this opportunity to hit the target and join the emerging big data field. Thank you. Introduction. This first section is just an overview of what the SAS statistical software application is all about. The purpose here is to make you familiar with the working of SAS application so that you can begin writing programs to manage and analyze the data that you have collected. We will go little slowly for the first 3 sections so that you can keep your eyes on important syntax rules that SAS application expects from the user in order to perform the specific task. Learning objectives and outcomes for this section. You will be learning the basic syntax rules for all SAS statements and SAS names. You will learn the basic structure of a data step and a proc step. You will also be able to identify the type of information contained in the descriptor portion of a SAS dataset. You will be able to identify the observations and variables contained in a SAS dataset. You will get familiar with the 6 possible attributes of a variable contained in a SAS dataset. You will be able to distinguish between numeric and character variables. You will be able to identify the 5 different types of SAS windows and understand their functioning. You will be able to execute or run a program in SAS. Then you will be able to ready to know the guidelines for good formatting and commenting of computer programs that you are expected to follow throughout your SAS programming. You will be able to use the enhanced SAS editor window to modify a simple SAS program. That's it for now. See you in next lecture. Well friends, I know it is little boring to go through theory part of SAS programming and its application, but it is mandatory since you need to know what you are going to do after learning SAS programming. Well, let us go through definition of SAS. SAS is a 4th generation programming language. That is a programming language designed with a specific purpose in mind, such as the development of commercial business software. All 4th generation languages are designed to reduce programming effort and minimize the time and cost it takes to develop software. It can be used to enter, retrieve, and manage your data easily, create slick reports and pretty pictures, analyze your data statistically and mathematically, plan, forecast, and make decisions concerning your business, manage your projects and perform research on how you conduct your operations, improve the quality of your processes as well as develop entirely new software applications. It can also be used for many large-scale applications such as data warehousing, data mining, human resource management, decision support, and financial management. Datasets that are stored as text files have a .txt or .dat extension while SAS datasets have a .SAS7BDAT extension. We will be usually saving the datasets to a specific location on our computers so that we can use them within the SAS application. That's it for now. Thanks. Before we go to practical SAS programming, before that, let us get familiar with the SAS rules and regulations. Here, this program reads in a set of grades for 6 students and prints out their student numbers and genders. As here you can see that we are reading the data in data step and printing by use of proc print step. Here we are reading the data of 6 students, 1st, 2nd, 3rd, 4th, 5th, 6th, and we are reading the variables subject, gender, exam 1 marks, exam 2 marks and homework grade. Since the second column and the last column are alphabetical in nature, that is categorical in nature, so we have placed $sign just after the name of their variable. The basic requirement for SAS statements are all SAS statements must end with a semicolon. As here you can notice that data statement is ending with a semicolon, and similarly input statement, data line statement, run statement, proc print statement, var statement and run statement is ending up with semicolon. But there is some exception to the data that is contained in the program itself, as here you can notice that we have only one semicolon for complete data. SAS statements typically begin with a SAS keyword, example, options, title, data, input, data lines, run, proc and var. SAS programs can be freely formatted. That means any number of SAS statements can appear on a single line provided they are separated by a semicolon. As here you can notice that we have var statement and comment statement in one line. Now let me run this program. As here you can see that this is our output that we have got. Now let me take this comment to the other line and rerun this program. And here you can notice that we are still getting the same output. A SAS statement can be continued from one line to the next as long as no word is separate there. As here you can notice that our input statement is separated into 2 lines. Now let me split into 3 lines and rerun our program. You can see that still I am getting the correct output. SAS statements can begin in any column. It means that you can write SAS statement in any column. Let me shift this input statement to nth column and rerun this program. As here you can see that still we are getting the correct output. SAS statements are not case sensitive, that is they can be entered in lowercase, uppercase or the mixture of the two. Example input statement as you can see here. The words in a SAS statements are separated by blanks or special characters. In our case, we have separated them by blanks. Comments are used to annotate your program. 2 methods are there. A delimited comment begins with a /* and ends with an */ All text within the delimiters is ignored by SAS. An alternative comment begins with an asterisk and ends with a semicolon. As here you can see that here is our first type of comment and here is our second type of comment. Rules for SAS names. SAS names are used for SAS dataset names, variable names and other such items. Example, dataset name grade. Example, variable names subject, gender, exam 1, exam 2 and homework grade. Note that each of the names appearing in the program adhere to the following rules. All names must be between 1 and 32 characters. The first character appearing in a name must be a letter, either capital or small, or an underscore. Subsequent characters must be letters, numbers or underscores. That is, no other characters such as dollar, percentage or ampersand are permitted. Blanks also cannot appear in SAS names. SAS names are not case sensitive. That is, they can be entered in lowercase, uppercase or a mixture of the two. SAS is only case sensitive within quotation marks. That's it for now. See you in next lecture. Thanks. Proc steps and data steps are the basic building block of any SAS program, where Proc stands for procedure. Data step: any portion of a SAS program that begins with a data statement and ends with a run statement, another data statement, or a proc statement. As here you can see that the portion that is lying between the data statement and the run statement forms one data step. And also in this example, the portion that lies between the data statement and the proc print statement forms this data step. Here I have not used run statement in order to clear your concept. In general, data steps are used to manage data, that is to read data into SAS dataset, to modify data values, to check for and correct data errors, and to subset or merge datasets. Example: all of the statements appearing between the data grade statement and the first run statement make up the one and only one data step appearing in the program. Proc step: any portion of a SAS program that begins with the proc statement and ends with the run statement, a data statement, or another proc statement. As you can notice here, this forms the proc step. In general, proc steps are used for analyzing data, that is for calculating descriptive statistics, to generate summary reports, and to create summary graphs and charts. Example: all of the statements appearing between the proc print data equal to grade statement and the second run statement make up one proc step. Note: though SAS will execute most of the data and proc statements even in absence of run statement, but as a good programmer, we will always use run statements separately for closing each data and proc step. Also, both proc and data statements are separate operations, so they cannot be intermixed. That is, you cannot combine a proc step within a data step and vice versa. I know you might be thinking, is this just a theory-based course? Well, then the answer is no. You will take part in solving the demonstration exercises and practice exercises from section 3 onwards. But before that, you need to sit back, relax, and listen to me carefully without worrying about anything else, since this theory will be acting as the building block in SAS programming for your entire life. See you in next lecture. That's it for now. Before I start this lecture, let me tell you, you need not worry about the processes involved in getting this output, since I will teach you everything: making label heading of your choice, printing output in your own way, printing descriptor portions using proc contents. For the time being, just relax. I am covering up this because these basics are important, especially for interview and your knowledge. SAS datasets. In order to analyze our data, SAS application must read our data into a SAS dataset. A SAS dataset is a file containing that have two parts, a descriptor portion and a data portion. In this lecture, we will be talking about this program. The descriptor portion of a SAS dataset contains the vital statistics of the dataset, such as name of the dataset, date and time that the dataset was created, number of observations, and the number of variables. As you can see, the name of the dataset, grade, is present here, the date of creation, the number of observations, that is number of rows, number of variables, that is number of columns, can be seen from the descriptor portion of a SAS dataset. The data portion of a SAS dataset is a collection of data values that are arranged in a rectangular table. As you can see, this is our data portion. SAS dataset is comprised of variables, that is column, and observations, that is rows. Variables are collections of data values that describe a particular characteristic of the thing being measured. A SAS dataset can store thousands of variables. Observations are collections of data values that typically relate to one particular object. A SAS dataset can store any number of observations. In this example, we have 6 observations and 5 variables, that is subject, gender, exam 1, exam 2, and homework grade. SAS variables. You might have noticed two types of variables being used in dataset portion, that is character and numeric variables. The 6 attributes that SAS stores in the descriptor portion of every SAS dataset are the variable's name, the variable's type, the variable's length, the variable's format, the variable's in format, and the variable's label. As you can see that it is mandatory to have these first 3 attributes, whereas the next three are optional. For our current program, you can see that we have only used the first three, so we have got variable name, its type and length. Whereas if I have used this program with label statement, then I would have got label attribute as well. That's it. See you in next lecture. Let us explore each of the 6 attributes briefly. Variable names follow same naming conventions to that of SAS naming conventions that we have learned previously. Variable types, it can be character or numeric. Character variables such as name can contain any character that you can make with your keyboard, like that of letters, numbers and even these symbols. Numeric variables, on the other hand, such as subject ID, height and weight, can contain only numeric values, namely the digits 0 through 9, a positive sign, a negative sign, a decimal place, and the capital letter E for scientific notation. Variable length. It gives information about how many bytes are used to store the variable in your computer's memory. Character variable can be up to 32,767 bytes long, whereas all numeric variables have a default length of 8. Numeric values, no matter how many digits they contain, are stored as floating point numbers in 8 bytes of storage unless you specify a different length. As here you can see that our all numeric variables by default are having length of 8. Another thing you might have noticed about our dataset above is that some information in the dataset is missing. That's okay. SAS can handle missing data. What SAS displays when a value is missing depends on the variable's type. As suggested by the above dataset, SAS displays a blank space for a missing character value and a period for a missing numeric value. Variables formats and informats. We will learn about these two attributes in greater detail later in this course. Variables format tells SAS how to write a variable's value in specific form. That is, how you would like your variable's values displayed in reports, that is, output. For example, you might want to tell SAS to display the value 8520 as $8520.00 or maybe in commas instead. Variable informats tell SAS how to read data values having a special form into standard SAS values. Variable labels. By default, many of the standard reports in SAS identify variables by their variable names. You can instead tell SAS to display more descriptive information about the variable by assigning a label to the variable, that is, descriptive label up to 256 characters long. Example, the variables height and weight were given the more descriptive labels of height in centimeter and weight in kg respectively, as you can see here. Let us now interact with the SAS Windows environment so that we can start with writing and running our own SAS programs. That's it for now. See you in next lecture. SAS Windows environment. This is how our SAS Windows looks like. Editor window. Here you can type in your SAS programs. It allows you to perform standard editing tasks such as entering, editing and submitting programs. You can also open previously saved SAS programs as well as save new SAS programs. In order to run or execute your program, click on the Running Man icon button as you can see here. Output window. Here you can see our output window where the printable results from your program appear. Example, data listings, table summaries, charts, and character-based plots and graphs. If some output that you expected is missing or wrong, then double-check the log window to see for any programming errors that prevented SAS from executing your commands. Note that it is not mandatory that all SAS programs will be creating their output in the output window. For example, if you create HTML output, then it can be viewed in the internal SAS browser called the Result Viewer window. If you create a graph, it will appear in a separate graph window. This is how same output appears in our output window and Result Viewer window. Since it is same, so in our lectures we will be using either of them as per our choice. Mostly we will stick with Result Viewer window because it is nice in display. Now let me show you how you can select the output window or result viewer window. For that you need to open up this dialog box. For that you need to go to Tools, then Options, then Preference, and there you need to check mark this Create Listing in case you want your output in output window. Else you can check mark this Create HTML in case you want your output to be in result viewer window. Log window. This is how our log window looks like. Log window is the most important window in SAS programming. You must check this window even after you have programmed correctly. Even though your program may appear to have run correctly, critical errors may still have occurred when reading or manipulating the data. So, always check log window after watching your output window. You will get various kinds of messages in log window. For example, data and proc steps messages in black color, notes in blue color that SAS wants to report, warnings in green color that SAS wants to draw your attention, and errors in red color that cause SAS to abort running your program. You should always check log window in order to avoid wrong output. Explorer window. This is how our Explorer window looks like. We will explore it further in the upcoming lectures, but usually it is used to explore various kinds of datasets. That's it. See you in next lecture. Good programming practices and commenting SAS programs. Throughout this course, you should plan on adhering to the following guidelines. Although SAS allows for free formatting of code, but a good SAS program will be well organized. Proc or data steps within your SAS program should be separated by at least one blank line. As here you can see that we have separated this data step from proc step by one line. Use delimited comment for every SAS program, that is, this delimited comment. As here you can see that within delimited comment we can use file name, written by, date of creation, summary, that is what actually your program does, input, and the output you are expecting to get from the program. Every critical data step or proc step should be preceded by a block of comments so that it is easy to understand program at later stage in life while modifying it. Use comments for a single line formula used. As here you can see that we are calculating final length from the formula, that is initial length multiplied by change in temperature, and correspondingly we have used comments regarding this formula. It is useful to capitalize proc, proc name, data, and run. As here you can see that we have capitalized important keywords like data, run, proc and its proc name, that is print, run, proc contents. Here proc name is contents, then run, and so on. Also we need to offset by at least 2 spaces other blocks of code that will make reading easy. As here you can see that we have offset other blocks of code, that is input statement, label statement, and so on, by at least 2 blank spaces. Now let me show you a little trick. For example, if you want to shift this block of set of statements to the right, then select these statements and click on Tab key. And on the other hand, if you want to shift this set of statements to the left side, then click Shift Tab key. In the next lesson, we will spend some time learning how to read into the SAS datasets that the SAS system understands. Note: in the upcoming 2 sections, we will be going little slow, so as to build the strong fundamentals. If you have headphones, please do use that for better concentration. That's it for now. See you in next lecture. Thanks. Reading data into a SAS dataset. Here we will learn methods that will work in many situations to get your data read into a SAS dataset so that at later stage we can analyze that data. When reading data into a SAS dataset, you always need to tell SAS 3 things, that is, where your data reside, method to be used for reading data based on the format of the data, the kind of SAS dataset that you want to create. In where your data reside, your data can be in-stream data, that is embedded within your SAS program, Or it can be data contained in a raw data file that is external to your SAS program, or data contained already in another SAS dataset. There are three methods for reading data based on the format of the data. These are column input, list input, formatted input. In column input, data values are arranged in neatly defined columns. List input, in it, data values are separated by at least one blank space. In formatted input, data values contain special type of data like that of dates. The kind of SAS dataset. It can be of permanent nature or temporary nature. Learning objectives and outcomes. Upon completing this lesson, you should be able to do the following. Read instant data into SAS using a data lines or card statement. Read data into SAS from an external raw data file using an infile statement. Use the set statement to read data into a SAS dataset from another SAS datasets. Know how to create temporary SAS datasets. Use the libname statement to create a new SAS data library. Know how to create permanent SAS datasets. Be able to read data into SAS using column input. In the next lesson, we will spend some time learning how to read instant data into the SAS dataset that the SAS system understands. Note, if you have headphones or earphones, please do use that for better concentration. That's it. See you in next lecture. Thanks. This is our dataset that we are going to utilize. Reading instant data. As you can notice, our data is in well-defined columns, so we will read data by column input. The data line statement tells us to expect instant data. This is our data lines. Must be the last statement to appear in the data step, that is except for the run statement. This is our last statement in the data step. Must immediately precede the data, that is there should be no blank line between the data lines and the data. I mean there should be no blank space as such. Must be closed by a null statement, that is a single semicolon. As here you can notice, only one data line statement can appear in a data step. As you can notice, only there is one data line statement in one data step. Input statement tells us the form of the data. Here we use column input because the data values are standard character or numeric values and arranged in neatly defined columns. As you can notice here, these are in well-defined columns. Standard numeric data values can contain only numbers, decimal points, numbers in scientific notation, and plus or minus signs. We specify a valid SAS variable name, a type, character or numeric, and the number of the column in which the field starts and the number of the column in which the field ends, separated by a dash. If you intend for the variable to be a character variable, place one blank space and then a dollar sign right after the variable's name in the input statement. As here you can notice, subject, gender, height, weight, and blood are the variable name. Then, since the blood is a character variable, so we have used one blank space and then dollar sign. And also, as you can notice, the number of the column. Subject is starting from first column till fourth column, and fifth column is empty, and in the sixth column gender is being read, that is 1 or 2, and then height, and the process goes on. The data statement tells whether the dataset that you intend to create should be temporary or permanent. We will learn more about it later in this course. In our program, data statement tells us to create a temporary dataset called temp1. Tip: because it is one level name such as temp1, rather than a two-level name such as stat.temp1. Temporary dataset exists only until the end of your current SAS session. That is, once you close out your SAS session, the SAS dataset is removed from your memory and would have to be created again if you needed to use it again. The card statement is an alias for the dataline statement. That is, you can replace dataline with cards and rerun the program without affecting the output. In case I have used here cards, then also output will remain same, as you can notice. If any of your data values contain semicolon, then the, the dataline statement will not work. Instead, you must replace the dataline statement with the dataline for statement and the null statement with that of for semicolon. Let me show you. Here we will use datalines for and for semicolons. That's it. Thanks. SAS Data Libraries. Before we go for temporary and permanent SAS datasets, we need to understand SAS Data Libraries. In short, a SAS library is simply a collection of SAS files that are stored in the same folder or directory on your computer. Other files with different extensions can be stored in the same folder or directory, but only the files that have SAS file extensions are recognized as part of the SAS library. Depending on this library name that you use when you create a SAS file, such as a SAS dataset, SAS files are stored either temporarily or permanently as follows. If, when creating a SAS file, you use the library name work, or you don't specify a library name at all, then the file is stored in a temporary SAS library called work. That is, when you close out the current SAS session in which you created that SAS file, the temporary library and all of its files will automatically be removed from your computer's memory. If you use a library name other than the default library name work when creating a SAS file, then the file is stored permanently until you delete it. That is, you can use permanent SAS libraries and their contents in subsequent SAS sessions. Referencing permanent SAS files. SAS always refers to the dataset by a two-level name, libref.filename, regardless of whether a SAS dataset is temporary or permanent dataset, where libref is the nickname that you give to the SAS data library that contains the SAS dataset and file name is the name of the file itself. Example, in order to print the permanent dataset called background that is stored in the SAS library called stat, we have to refer to the permanently stored SAS dataset as stat.background, where stat will be acting as libref and background will be acting as file name. Here is example, proc print data equal stat.background. Referencing temporary SAS files. We know the libref of a temporary dataset is always work, so any SAS dataset stored in work libref will be temporary. Example, work.filename. Although SAS always refers to SAS datasets by their two-level names, but in this case, SAS lets you take a shortcut by using just one level name for temporary datasets. That is, when you specify a one-level name, the default libref work is assumed by SAS. Example, work.temp1 is equivalent to temp1, as you can see here. Defining libraries. We use a libname statement to tell SAS to associate a name called a libref to one of the folders or directories on your computer that contains SAS files. For example, I have a subdirectory on my computer at this address. But before we go to that, let me show you one thing, that this file is a SAS dataset with extension .sas7bd80, whereas this file is a SAS program with extension .sas. To tell SAS to associate the libref stat with this subdirectory, we simply use a libname statement as follows. As here you can see that this is the libname statement that I have written here just after the options statement. And also you can see in Explorer window we have libraries, and within it you can see that we have work library that is temporary in nature. And here you can see that stat library that is permanent in nature. And this is SAS help library which provides some permanent datasets by default for demonstration purpose. Now let me show you one example from the upcoming lecture. As here you can see that I have used libname statement with this specific address, and here you can see that we have no file at this address. Now let me run this program. After running this program you can see that we have got this file temp2.7sbd80, which means it is a dataset that is permanent in nature. Also let me show you this temp2 dataset in directory stat. For that we need to go to Explorer window. Here in stat folder you can see that we have this dataset present. In general, the libref can be a nickname of your choice, not more than 8 characters long, and should begin with a letter or underscore, and contains only letters, numbers, or underscores. You can use as many libname statements in a program as necessary to assign the librefs that you need. After submitting our libname statement, check out your log window for similar message. As you can see here, libname statement is a global statement. Our stat libref will remain in effect until we have modified it, cancelled it, or ended the SAS session. In the next lesson, we will learn reading data into permanent SAS datasets. That's it. See you in next lecture. Thanks. Here in the SAS program, data is read into temporary SAS dataset, that is temp1. In order to read data into permanent SAS datasets, first of all, create subdirectory on your computer where you want store permanent SAS datasets. As here, at this location, I am going to create new folder wr and copy this address of subdirectory. And here I am going to write lib name, directory name, stat, in quotations, subdirectory address, then semicolon. Apart from that, I am also going to change this one level name to two level name. Stat dot, this stat is same as this stat, and similarly here as well, stat dot. Let us change temp1 to temp2 in order to differentiate, and here also write temp2 and run this program. Libname statement tells us which of our directories we want the data permanently written. Here the SAS dataset is written to our this subdirectory. The name of the dataset will be two-level name. This is how SAS will come to know to put the permanent dataset temp2 in our subdirectory. In subsequent procedures like print procedures, here we will have to refer to the permanent dataset by its two-level name. Well, everything will remain same except when you go to Explorer, and this is our directory, as you can notice, stat, and here we have our permanent SAS dataset temp2, and in work directory we have our temporary dataset that is temp1. That's it. See you in next lecture. Thanks. Reading from a raw data file. So far we have read instant data into SAS datasets that is embedded within program. Now let us learn how to read data from a raw data file into SAS datasets. A raw data file is an external text file whose records contain data values that are arranged in the fields. Typical file name extensions are .dat and .txt. A raw data file, also commonly called an ASCII file, is a kind of data file that is generally viewed using softwares like Notepad, WordPad, etc. Note: datasets stored in spreadsheets such as Microsoft Excel are binary, not raw ASCII data files. Well, this is the file that we are going to read, that is temp3.dat, and it is placed at this address. And this is the program where we are reading in-stream data into temporary dataset, that is temp3. Let me convert this program so that we read data from external source. For that, I have to write here in file and within quotations the address of the file and also the name of the file, that is temp3 with extension .dat, and then semicolon. That's it. Rest everything will remain same. And let me run this program. It will not work because I have written temp. Let me write temp3.dat and we have got our output, as you can notice, and in log window it is fine. The infile statement tells SAS where the raw data file is stored on your computer, which must precede the input statement, merely replaces the data lines statement and the data lines. Note: instead of identifying the raw data file by specifying the entire file name and location in the infile statement, we can alternatively use what is called the file ref. Just as we used libname statement to assign a libref, we use a file name statement to assign a file ref. File refs perform the same function as librefs, that is, they temporarily point to a storage location for data. However, librefs point to SAS Data Libraries, whereas the file refs point to external data files. Let me show you that. Here we are going to use file name similar to libname and then some name of your choice, let it be stud. Then within quotations we are going to write this address and here we are going to write this file name stud and then semicolon and run this program and it will work fine. That's it. Thank you. Reading column input. As stated previously, three different styles of input that are available to us in SAS are: column input, that allows you to read data values that are entered in fixed columns; list input allows you to read data by simply listing the variable names in the input statement. At least one space or character must occur between each value in the dataset. Formatted input allows you to read numeric data containing special characters such as data and $amounts. Note: we will use the data lines statement to read in data, though infile statement process of reading data from external source is also valid. We will create temporary datasets rather than permanent ones, though both are valid. After each SAS data step, we will use the SAS print procedure, that is proc print, to print the resulting SAS dataset for your satisfaction or analyzation. Column input. To use column input, your raw data must be in a fixed columns and in standard character or numeric format, as it allows you to read variable values that occupy the same columns within each record. List the variable names in the input statement immediately following each variable name with its corresponding column position. in each of the data line. Remember, character variable is followed by a dollar sign. Column input reads data values until it reaches the last specified column for the field. This is an example that you should analyze. Important points for column input. Missing values can be left as blank. That is, no need to indicate missing values with a placeholder such as period. As here, the character values can exceed the default 8 characters and can have embedded spaces, as column input uses columns specified to determine the length of character variables. It also allows fields, that is, columns, to be skipped altogether or to read in any order. Column input allows only part of a value to be read and allows value to be reread as well. Spaces are not required between the data values. Well, take some time to understand the above points. See you in next lecture. Here in this program, we are going to read column input data. First of all, we need to create the name of the dataset, data, temp, semicolon, then input. After that, data lines, and then the data that you want to read. After that, one semicolon, and then run statement. And by leaving one blank line, we will write proc print data equal to name of the dataset that you want to print, and then run statement. And in between, if you wish, you can write title within quotations. Let it be output data set temp. And here in input, we are going to write the variable name. First will be subject, then space. After that, write 1 to 4 space name, and take out the variable that will cover all the possibilities. As here, Benedictine Arnold is the longest and it have value that is 6 to 23rd column, and same process goes on. And then let me run this program, and here we have got our output dataset temp3, subject, name, gender, height, weight. And the point to be noted is that in column input we can read characters even more than 8 characters. And another thing that I want to show here is that even you can reread the columns, and also you can skip any columns. For that, I have this dataset. We will be using these data lines. Here, name is missing and we have not placed any placeholder, and similarly height is also missing for Thomas Jones. What I am going to show you here is that here we are going to read first initial, that is for alias A, Marias M, Thomas T, which is 6th column, and the first name with dollar sign, since it is a character variable, goes from 6 to 16, And for last name, it goes from 18 to 23, and the same process goes on. Here another thing to be pointed out is that weight is read before that of height. Let me run this program, and as you can see, F initial, first name, last name, weight, height. And since height is a numeric variable, so we have got this dot, and whereas for F name we have got blank space, and here also blank space. That's it. Thank you. Reading data from external or other SAS datasets. So far, we have seen how to read in-stream data into a SAS dataset, how to read data contained in an external raw data file into a SAS dataset. Now, we will see how to read data already contained in one SAS dataset into another SAS dataset. This was the program that we used previously to create dataset, that is stat.temp2, that is stored in stat directory, and here you can see. Well, now I am going to show you how to read this dataset temp2. First of all, we need to create new program, and here I need to write lib name statement, lib name, and the location within quotations. Here I need to write copy this location, and that's it. After that, I will be writing data, the name of the dataset that you want to create, then set statement, and then the name of the dataset that you want to read. Here it is stat temp2, and then a run statement. Here I will be using proc print data equal to temp, and run, and within it I will be writing some title, output dataset temp. That's it. Let me run this program, and here you can see we have got our program, and it is exactly the same with that of temp2. In this case, as one level name is used in the data statement that tells SAS to create a temporary data set called temp. The set statement tells SAS to assign the data, that is observed by observation in exact format in the existing permanent SAS dataset stat.temp2 to the temporary dataset appearing in the data statement. Because the variables in the existing dataset have already been named, no input statement is necessary. That is, the set statement indicates that the data being read are already in the structure of a SAS dataset, and therefore merely gives the name of the dataset. That's it. Thank you. In this lesson, we realized that we must know three things: where your data reside, format of our data, whether you want to create a temporary or permanent SAS dataset. Tip: use a data lines statement if you are reading stream data. Use an infile statement if you are reading data from a raw data file. Use a set statement if you are reading data from another SAS dataset. Use an input statement with proper column numbers to read arranged in well-defined columns. Use a two-level name in the data statement for creating a permanent SAS dataset. Use a one-level name in the data statement for creating a temporary SAS dataset. That's it. Take some time to understand the above points. See you in next lecture.